and stuff like that. Reduce that.
Square, or sorry, you can do square root 8, square root 10.
Notice that you don't ever want to do that. And the reason is that neither of those is a perfect square number. So you always want to make sure you do want to factor 80, but you want to make sure one of the factors is a perfect square number.
Sorry, I didn't think about that correctly. It's 4 and 20.
Okay, that's one way to do it. So what's that equal to?
2 root 20.
Is that simplified?
Yes.
Actually not. Root 20 can be root 4 times root 5.
So that'd be 4 root 5.
Right. Now, notice that if you realize that 80 was also root 16 times root 5, you can get there in one step. In other words, you go immediately to 4 root 5. The key thing here is that you don't ever have to do that. You don't ever have to find the maximum perfect square number. You just have to find a perfect square number and whittle it down. So a really good list to memorize are these set of numbers right here. What are those? Those are your perfect square numbers. So whenever you're looking to factor whatever number you have inside the radical sign, start by trying those numbers. In other words, most of the time you're going to realize that 4 is one of them. I'd say that 80% of the radical problems I see, you can divide by 4. So that's one to usually check immediately. I'm going to erase those. I think you probably have those memorized.
You can't simplify that.
Good. Square root of 200.
Square root 100 times square root 2. The root of 100 is 10, so it would be 10 root 2.
Good. Now, hold it. Before you do this one, do this one. Remember that the square root a over b is the square root of a over the square root of b.
So multiply numerator and denominator by root 4.
Don't need to. In other words, let's do the first.
They're both squares, so it'd be 3 over 2.
Right, exactly.
I didn't see that.
Okay. Now do this one.
You can multiply by root 2.
Well, do the first step. Don't neglect that first step. Make things so easier.
Root 1 over root 2. Multiply by root 2.
Now how do we... That's not a proper answer because we have an irrational denominator.
So multiply numerator and denominator by root 2. We get 1 root 2 over root 4, which root 4 square rooted is 2, so you'd have 1 root 2 over 2.
Right. Always remember that the square root of x times the square root of x is always x, regardless of what x is. I don't know whether you've gotten to this level or not. In other words, primarily, the reason they reviewed radicals as the start of the second semester was because whenever you're solving right triangles, your answer always begins with square root of. So you are constantly reducing or simplifying radicals. So not as likely to run into a problem like this just solving right triangles, but nonetheless, it's useful to know how to do this. And you will eventually get to this. Maybe, I don't know, maybe not till algebra 2, but nonetheless, what do you think this is? Separate it.
X squared times square root x. So it would be x root x.
That's it. And one last one before we go from this subject.
Root x to the fourth. No, that wouldn't work out.
Yeah, no, that's first step.
Root x to the fourth, root x, and you'd have x squared root x.
Good. Solve for x.
Is this a 30-60 or a 45-45?
No, it's not one of the special triangles. This is just a normal right triangle that you have two of the three sides.
So it'd be...
Let's start out with that problem right there. What is this?
Sorry, what?
Let's use this triangle where the hypotenuse is 7 and this side is 2. Solve for x.
X equals root 45.
Okay.
So that'd be...
Yeah. In other words, I don't really care about the answer. What I'm mainly looking for is, did you do it this way?
Minus 2 squared.
Right?
Right.
Which is root 45. Simplify root 45.
Root 9 by root 5, so you'd have 3 root 5.
Good. Now we'll make it a square root of 7 instead. So now what is x?
So that'd be x equals square root of 7 minus 7 minus 4.
All right. Obviously, your test was on these kind of problems, so we don't need to review those anymore. Let me just check the book to make sure I know. Do you happen to know what's coming up next? I see trig ratios.
Yeah, we're moving on to trig stuff.
Okay. Let's do some trig. You've had a little trig, right?
No, I haven't had any.
None. Well, this is where you want to start. This stands for the sine is the opposite over the hypotenuse. This means the cosine is the adjacent over the hypotenuse. And this means the tangent is the opposite over the adjacent. In other words, each one of these things has a little implied over right there.
Mm-hmm.
In other words, the O does not stand for over. The O stands for opposite. So if I have a 3, 4, 5 triangle, tell me what the sine of theta. When you take trig functions, you are always taking trig functions of angles. And you're always getting ratios. So what would the sine of theta equal? What's opposite? What's the side opposite theta?
3.
What's the hypotenuse?
5.
What is the cosine of theta? When they say the adjacent, there's two sides that are adjacent to every angle, right?
Mm-hmm.
They always mean the one that is not the hypotenuse. So there's no ambiguity. In other words, just like opposite means only this side right here, adjacent means only that side right there. It's whatever side is adjacent to theta and not the hypotenuse, which is only...
Oh. So it's 4?
So it's 4 over 5. And finally, the tangent of theta is what?
What's the tangent?
What's the tangent of theta?
5?
No, it's opposite over adjacent. 3 is the opposite. The adjacent is 4.
Okay.
Okay. All right, let's switch things up a little bit here. Now, it's really important to know which angle you're talking about. In other words, if I ask you what the sine of theta is here, there's no way to answer it because I haven't told you where theta is. Incidentally, theta is never the right angle. But it can be either of these two angles. In other words, I could make that an angle, and I'm going to call it delta. Okay, I could call it theta. No other angle is labeled theta. It's just when you label angles, they're usually labeled with Greek letters like alpha, omega, delta, theta, those kind of Greek letters.
Mm-hmm.
What's the sine of delta? I'm not even sure that's delta. That's a Greek letter, but we'll call it delta. You'd think I would know my Greek letters better, but I don't. What's the sine of delta?
Twelve over 13.
Good. Cosine of delta?
What does the C stand for again?
Cosine. In other words,
Okay.
There's your sine, cosine, tangent. Correct? 5 over 13, right? And what's the tangent of delta?
It would be 12 over 5.
Okay? Now, let's change it so that that's not a right angle. Let's make that 11, because I can't leave the dimensions the same. In other words, you learned that not only does the Pythagorean theorem apply, but if this side squared plus this side squared equals that side squared, then it has to be a right triangle. So I could not say make this angle something other than a right angle and leave these dimensions the same. But if I change the dimensions, now I can say that's not a right triangle. Now what's the sign of delta? Don't say it.
Okay, so it's 11 over 5?
No. You can't.
Or 11 over...
You can't do it if it's not a right triangle. That's why I said no. I was trying to be tricky.
Okay.
In other words, if, say I have, let me draw it so that it's not even close to a right triangle. Draw it so that it looks something like this. This is 5, 6, 7, and that's theta. You do not know what the sine of theta is because it's not a right triangle. In other words, these definitions apply only to right triangles. Now, it does make a lot of sense. We use trig functions to non-right triangles also. But this semester, you're probably only going to get right triangle trigonometry.
Yeah.
And so I would not be able to tell you what the sine of theta was there. I would have to figure out what theta was using complex trig, and then I would know what the sine of theta is. In other words, here's the thing. The sine of 30 degrees is always the same ratio, regardless. Let's talk about that for a moment. Notice that in my special unit triangle, which is a right triangle, the sine of 30 degrees is 1/2. Well, if I make a similar triangle, only bigger, so that this is 2 root 3, this is 2, and this is 4. Are you with me?
Mm-hmm.
They're both similar. They don't look it, but only because I ran out of room. Well, what's the sine of 30 degrees in this triangle, which is also a right triangle? 2 over 4.
Yep.
Okay? So when you do get a value for a trig function, it is always that. In other words, the sine of 30 degrees, no matter the triangle, is always 1/2. And you end up actually with a table of values. In other words, that's why your calculator can give you, what kind of calculator do you use, Cole?
I have an Inspire.
Okay. The Inspire actually has all 6 trig functions on it, which is different from the TI-84, which is kind of the last generation calculator. And the reason this, whatever you call that, an acronym, the reason it's been around for so long is because all calculators since the beginning of the calculator, which was 1970, have only had the 3 primary trig functions, sine, cosine, and tangent. Okay? Sine, cosine, tangent. There's actually 6 trig functions. There's cotangent, there is secant, and there's also cosecant. Well, these were never listed on calculators until they came out with the Inspire. Now, if you go on your Inspire and you hit the trig key, it'll ask you which of the 6 trig functions do you want to talk about. It'll also ask you about the 6 inverse trig functions. So it actually gives you a menu of 12 things to pick from. But these three here, the reason they're not on the original calculators is because you didn't really need them. Each of these, and I'll call them secondary trig functions. Let's call these primary, the three on the left, and let's call these secondary. Even though there's nothing secondary about them, all six trig functions are equally important. It's just that each of these three secondaries is the reciprocal of the primary. Cotangent is reciprocal of tangent. Cosine is reciprocal of secant. And cosecant is reciprocal of sine. So this is the relationship between the secondary trig functions and the first ones. And if this is true, well then this also has to be true. Cosecant of theta equals 1 over sine theta. So if I said the sine of theta equals 1/2, well then the cosecant of theta must equal 2. Right? It's always the reciprocal. So whatever this function is over here, this one's going to be the reciprocal. It's going to have the same sign on it, plus or minus, whatever it is. And incidentally, each of these can have a plus or minus on it, even though it's hard to see that from looking at right triangles. You're going to say, well, how does it ever get minus? Well, as soon as you start talking about trig functions that are greater than 90 degrees, then you introduce negative ratios also. So they can be plus or minus, but this reciprocal is always going to be the same plus or minus sign as this one is. Likewise with all three of these. So, let's put up a triangle on there. Put up our 30/60 again. What is the cosine of 60 degrees?
Cosines would be 1 over 2.
Good. What's the sine of 30?
The sine would be 1 over 2.
Right. So there's another relationship. The sine of any angle is equal to the cosine of 90 degrees minus that angle. In other words, the angle I just gave you was 30 degrees. Well, this is 1/2. Cosine of 60 degrees is 1/2. So you have these properties called the cofunction properties, which exist between any trig function and the same name with co in front of it. In other words, the cosine is the cofunction of sine. The cotangent is the cofunction of tangent, which means tangent of theta equals cotangent of 90 degrees minus theta, and vice versa. In other words, cosine of theta is also equal to sine of 90 degrees minus theta. And finally, the third cofunction relationship is secant of theta equals cosecant of 90 degrees minus theta. Now, what trig ends up being is a ton of memorization. More memorization in trig than all the rest of your geometry put together, probably. Even though you're just going to get a taste of trig, you might not even get these cofunction properties this year. So back to this little triangle over here. What is the cosecant? What's the cotangent of 30 degrees? Cotangent of 30 degrees. And you can do this two ways. The way I normally do this problem is I figure out what the tangent is and then I flip it. That's the easiest way to do it.
Okay, so it's from 60 degrees, sorry?
No?
Oh, from 30. It would be, it would be root 3.
Good. Excellent. Which shows you something. Notice that if I started this problem by figuring out what the tangent of 30 is, which is 1 over root 3, and I look at that and I say, well, that needs rationalizing, so that turns into root 3 over 3. And now to figure out what the cotangent is, I got to flip it. So it's 3 over root 3, but now that needs rationalizing again, so it goes back to root 3.
Yep.
Moral of the story is don't rationalize until you get to the end, because sometimes you don't need to.
Couldn't you say that that the cotangent is just the adjacent to the angle?
No, because these numbers can all be different. In other words, let's say I'm not dealing with that specific triangle, but a triangle bigger than that. Same triangle, similar, but has these dimensions. Well, now the cotangent is going to be 2 root 3 over 2, which comes back down to just root 3.
Okay.
Okay, so the cotangent is always the adjacent over the opposite.
All right.
It's basically the reverse of that. And the secant is the hypotenuse over the adjacent, but I don't really memorize it like that, to be honest with you. In other words, I don't have a similar acronym for the other three. What you want to definitely memorize, though, is these reciprocal relationships. These are not co-relationships or co-function, they're reciprocal. And here's the easy way to memorize. Notice that in each of these pairs there is exactly one co, and always start with that one. Nobody forgets what the co or the reciprocal of tangent is. It's cotangent. That's easy. Okay? So there's one co right there in that pair. Go up to this pair, there is exactly one co in that pair. It's that co right there. And go up to this pair, and there's one co right there, cosecant. So a way to memorize these reciprocal relationships is to memorize the fact that in each pair there is only one co. In other words, sine is never going to go with secant. There's no cos in that. Cosine wouldn't ever go with cosecant. There's two cos in that. Just a helpful way to remember these reciprocals. And these are probably the most important next thing to memorize after that. In other words, if you said what were the 4 most important things in trig to memorize, SOHCAHTOA gets you started. And then these 3 reciprocals, and of course I can figure out the other 3 reciprocals. All right, that's a good place to stop.
All right.
Well, you'd probably be, I don't know, how long is this trig section? Well, trig is pretty useful in solving right triangles if you don't want to use the Pythagorean theorem. So, but I bet you probably won't be on trig anymore by next Monday. Maybe. But we'll do whatever you're on. Okay? You good?
All right.
All right, Cole. Have a good week. Talk to you next week.
You too.
Bye-bye.